Hello everyone, I am S. Shawali from Srinivasa Raman Institute of Technology with the Department of Electronics and Communication. This is the point representation of micro oven. The topics I have learned is Introduction to C, data types and their modifiers in a single or multi-iteration condition constructions, operators in C, arrays and pointers and functions. As we know that C is a high-level language and used for general purpose. And the general purpose programming language is developed by Dennis Ritchie at Bell Labs in 1970s. It is construction language that provides a low-level memory management and efficient execution. The features of C are portability, efficiency, flexibility, structured programming. It contains the basic syntaxes of array like variables, data types, operators, and control functions. If we come to the next thing, that is data types. Data types are integer types, float and point types, character types, and if we come to the type modifiers, it will be signed or unsigned, short, long, and long, long, long. In a single iteration condition constructs if statements, which is used for executing a block of code if a condition is true. If we come to the next if-else statements, which is used for executing different blocks of codes based on conditions. Switch statements used for executing different blocks of codes based on value of expression. For the multi-iterations, we use while, do while, and for loops. While loops are used for repeatedly executing a block of code while a condition is true. While do loops is used for repeatedly executing a block of code while a condition is true. Or for loop is used for executing a block of code for specified number of iterations. If we come to the operators in C, there are different types of operators such as arithmetic operators, comparison operators, logical operators, assignment operators, and bitwise operators, and so on. For each, there will be a specific form of construction. While in arithmetic operators, we use additional, subtraction, multiplication, division, modules, increment, and decrement. In the comparison operator, equal to, not equals to, greater than, and less than, we are comparing between the two specific tasks or variables. Logical, we are using and, or, and not. For assignments, we are additional assessments in a pre or after the process of equal to, in the subtraction, multiplication, division, and module assessments. In bitwise operators, we are using bitwise and, bitwise or, bitwise XOR, bitwise not, left shifting and right shifting. If we come to the next, pointers and arrays. As we know that array is a form of collections of the elements of the same data type stored in contiguous memory location. It is declared by using a square bracket syntax. And the pointer is a variable that stores the memory address of another variable declared using a star syntax. And the relation between the array and the pointers. The name of an array is an equivalent to a pointer to its fixed first element. Array elements can be accessed using pointer arithmetics. If we come to the functions, function a block of code that can be used multiple times for different parts of program. It can be arguments and return values too. If we come to the types of functions, it is library functions, user defined functions, and functions contains the parameters too, which is formal parameters and actual parameters. The function returns the types as void function, value returning functions. If you go to the next slide, the contents of this PPT will be microcontroller, what is embedded systems, embedded C, components of embedded C, and project review, project simulation, and summary. First, we will go with microcontrollers. We use microcontrollers in our daily life in so many situations. A microcontroller is a small computer on a single iterated circuits chips. It contains a processor, memory, input-output peripherals too. Microcontrollers are used in embedded systems to control and interact with external devices. It contains ROM, RAM, microprocessor, programming memory, input-output, oscillators, analog to digital converters, etc. The main difference of microcontrollers and processors are all are separate components, all components in a single chip. More flexibility in microcontrollers, less flexibility. More designing complexity, less design complexity. Embedded systems. An embedded system is a combination of hardware and software designed to perform a specific task. It is self-contained system operates within a larger system or a device. Embedded systems are used in various applications such as consumer electronics, individual controlling systems, and medical devices. If we go with the examples of embedded system in our daily life, traffic light controls. We might observe in traffic there will be a single purpose, which is the changing of the lights and giving the direction to move or to stop to ready the vehicles. The micro ovens, which shows the timer, is a specific task of embedded system which will be heated for a particular duration. Automated system, anti-braking system, navigation is the mostly we are using in every vehicles. So it is also one purpose of embedded system. Medical field. In medical field we are using insulin pumps and X-ray etc. Smart home devices as security systems and thermostats. Industrial control systems, we are using fingerprints for the recognition, and we are using so many such as scanning of the CCTVs etc. Wearable devices are smart watches, fitness trackers. Some common characteristics of embedded system includes specific task, real-time constraints, limited resources, self-contained, low power consumption. In specific tasks, embedded systems are designed to perform a specific task, such as controlling a robot, monitoring temperature, or managing a network. As we know that we are using TV remotes for a particular function, as for changing the channels or giving the instructions to a TV, etc. Real-time constants. Embedded systems often have a real-time constants, meaning they must have response to an event or a performed task within a specific time of frame. Limited resources. Embedded systems have specific type of peripherals such as memory of a particular durability, using a particular battery of power, and storage capacity, and such as specifications. Self-contained. Embedded systems are designed to operate independently often without the need for external devices or systems. It doesn't depend on another system, it will be within it. Low power consumption. Embedded systems are often designed for low power, making them suitable for battery level for using less battery power and high durability. Components. Components are hardware. The hardware, the physical building up blocks of a system, including a microcontroller, sensor, actuator, and other devices that interact within a physical world. As observed in the figure, there is a fingerprint and a switch, which is an hardware, or a keypad, which will be observing from the exterior. Application software. For the working of the hardware, there is need an application software. That is the software which can be work internally and used for input variables. The programming and the codes that runs on hardware performing a specific task and functions such as data processing, decision making and controls. As you are giving the inputs for the software and a hardware, by using the hardware, there will be an output so that there will be a specific task to be done within it. The real-time operating systems. Every device nowadays contains an operating system, a specified software layer that manages the application software and provides a framework for scheduling and management and ensuring the system's response to an event in predictable and timely manner. Benefits of embedded system. As we have said about a small in size, low power, low cost, real-time response, reliability, flexibility, mutability, and improved accuracy. As we said in the above components, hardware will be microcontrollers, memory will be RAM, ROM, EEPROM, input-output peripherals such as GPUs, UARTs, and sensors and actuators. While in the software form will be firmware which is coded with embedded C code. Operating system which is optional, as we said, some may not be used. And device drivers and applications software. Small inside so that it can be compact and lightweight. Low power, making them energy efficient. Low cost, so that every can be operated and use it. Time response provides a fast and predictable response to an event. Reliability is designed to operate reliable in rash environment. Flexibility is it can be customized to perform a specific task, and flexibility will becomes under flexibility of durability too. Embedded systems is automatic task increasing efficiency and productivity. In the development of the automation industry, we are using mostly sensors in today's generation. They can perform tasks with high accuracy and precision. As we are defining pre so that to do a specific task in a time so that will be accuracy. Trends in the development. As we know that there will be development in every technology so that it will be such as Internet of Things, increasing the connectivity and community between the devices. Example, smart home systems. As by clicking or by using the phone, we can control the lights, speakers, and all the things in a home. Like Amazon Echo or Google Homes. By using the voice, we are operating the external devices by our audio voice. It is also an Internet of Things. It comes under Internet of Things. By using the internet, we are controlling the things. That controlling the lights, temperature and security too. Cyber security. Ensuring the security and integrity of embedded systems against cyber threats. Ensuring the safety for our data, it will be with the cyber security. The management will be within entering the threats will be removed by using specific tasks as switching off or giving an user an identity or messaging it, etc. The security smart meters that protects us user data and prevent hacking. As in our today there will be phishing, man in the middle and different types of cyber attacks which can be using protected by cyber security. Real-time operating systems. Advancement in the real-time operating systems to support complex applications and ensure timely response, such as VS Works used in aerospace and defense applications. Embedded C. Embedded C is a variant of the C programming language used for development in embedded systems. It provides a platform-independent way of programming microcontrollers and other embedded devices. Embedded is used for developing firmware, which is a software that controls the hardware components and embedded system. It plays a key role in performing specific function by the processors. This is the project review. In this project, I have developed a program for micro oven with PixSimLab. In this project, micro ovens offer a precise temperature control, adjusting the cooking time and user-defined interface. Introduction of the micro oven. As we have seen in our daily life, we are using micro oven for heating purpose. Internally, the radiation of the electro waves by using an wave signal to get the electrons move fast and will be produced in our food. A micro oven is a kitchen application that uses electromagnetic waves to heat and cook the food. It works by producing a microwave energy that penetrates the food and causes the water molecules to vibrate and generating the heat. The key features will be fast cooking time, energy efficient, convenient, and reheating compact design. Micro oven converts electrical energy into the form of electromagnetic radiation called microwaves. The tools which is used in this project will be MPLab IDE. It is an integrated development environment. MPLab X C8 compiler. This is a COS compiler. Simulator. PixSimLab simulator using simulating tools. MPLab X Lab. It is an integrated development environment which I have said in the above slide, which we are using for embedded systems development with PixSim MCU microcontroller is called MPLab. It is a free integrated development environment for microchip technology used for developing, debugging and testing embedded systems, particularly those based on microchips. Widely used in the embedded system developments such as robotics, IoT developments, automation electronics and industrial automations. This is the logo which will be observed. Compiler. MPXC8 is a compiler which belongs to a family of compilers from microchip technology used for developing embedded systems, particularly those based on microchips, including the libraries for common tasks such as input-output, mathematical functions, and data conversion. Types of XC compilers are 8-bit PIC microcontroller, 16-bit PIC microcontroller, 32-bit microcontroller. We use the header file such as include xc.header file contains the definition of all registers of PIC16F877A microcontroller. A PixSimLab simulator. It is a simulator simulators are mostly used for coding using the XSimLab, which allows you at least to test and debug your code without physical hardware. Using the hardware tools within it with the software, we are using the simulator. The key features will be project management, coding editor and compiler and assembly, debugging and simulator will be in a PixSimLab. The user will be using a software which can be given an input peripherals to check whether it works or not. PixSimLab is a real-time simulator of development bots with MPLab with average GDB debugging integration. PixSimLab supports several devices spare parts that can be connected on the boarding for simulation. PixSimLab peripherals, input peripherals, output peripherals, and communicating peripherals and other. Input peripherals, we are using a switch, simulated digital input for switches. Keypad. Keypad will be seen in our daily life, such as in the old ways they will be seen in the phones as keypad phones, which contains the numbers and alphabets too. Simulates a keypad with multi keys. Potentiometer, which is used for adjusting the speed to increase or decrease. Simulator analog inputs from potentiometer. As potentiometer can be observed in the adjustment of fans speed the same way as the potentiometer works. The output peripherals, which give us the output signal for the user, like LED simulators, 7-segment displays and LCD displays. LEDs for the blinking, such as giving the signals in train so that the train will comes, such a way we will be using LEDs. And 7-segment displays, we are using the 7-segment display will be in stations like bus stations for and railway stations, in the trains, which trains the comes and which times the go. LCD displays. An LCD display is a liquid crystal display for text outputs. Communication peripherals. The internal storage or a registered communications will be observed in the communication peripherals to communicate the information to work which and where we have to store. UART, Universal Asynchronous Receiver or transmission. It is a serial communication using UART. This simulates a SPI is a serial peripheral interface communication. I2C is a inter-integrated circuit communication. Types of cooking modules: micro mode, grill mode, convection mode, and the start are the modes which will be seen in the display. Summary: the microcontrollers we are using is PIC16 F877A is a PIC simulator on the board of PICGen OS. XCS compiler used for writing the code and creating the hex files. The peripherals used are CLCD, Taxel switch, timer, LCDs, and fans and buzzers. The implementation of the 4 modes are micro mode, grill mode, convection mode, and start mode. This is the code which I have developed for working of micro oven project. This is the output. As the temperature is given, it will take the temperature as 30 increases, or we are entering the temperature. The timer will be initially decremented with the time decreasing with 1 second, 1 second, 1 second. It will be preheating, as we are observed here. It is preheating. The time. As it completes,
seconds is done, when it becomes 0.
as it completes, we can see the display of entering. If we give a timer, it will be increased by 30 to 30 seconds.
10 seconds. And enter. This clear screen should be implemented.
See, it will showing the 4 modules of start microcontroller modes like microcontroller, grill up, conventional start and start. If we enter by
And also
this
the other things,
keypad,
okay,
we
they
can
have
observe the
commands, I have to clear this.
modes on
Okay,
working.
when I go with start mode, we'll see. Yeah, start mode, it is starting with 30 seconds. So if I press 4,
The timer will be only 30 seconds. If we increase, the timer will be increased by 30 seconds.
time.
By the fan rotation, we can observe that it will be working. It is working. The code is working using the simulator. Thank you.